Hello, a Rosie math teacher coming at you from my 4th period accelerated grade 7 math class, where today we are working on lesson 13-4, last lesson in our textbooks. And then we'll be doing 3 weeks of review, but I'm super proud of my class for working so diligently and so quickly that we could get to this moment and have plenty of time for review before our big state testing. All right, it is called lesson 13-4, Make Predictions. At the top of the page, everybody go with me right now to item number 1. A number cube is rolled how many times, class? 30. Circle it. You're going to need that in just a moment. Don't know why my page does that sometimes. Based on the theoretical probability of, hold on, it's bothering me that line is too big. We were rolling it 30 times. Based on the theoretical probability, how many times is the cube expected to land on a what?
2.
On a 2. So when we're dealing with a number cube, also known as one of 2 dice, we would have how many numbers on there? 6. What numbers would they be? 1, 2, 3, 4, 5, 6. How many times will you see a 2 on a single number cube? Once. So please write your numerator of 1 out of what are all the possible outcomes on that number cube? 6. Class, do you understand why you're saying that theoretically speaking, the probability of you rolling that number cube and it landing on a 2 is 1 out of 6 possible outcomes, yes?
Yes.
Okay, so meaning if you were to roll it 6 times, you would anticipate somewhere around 1 time it would land on a 2. Okay, they want us to use this theoretical probability 1 time out of 6 times and equate that to how many times out of 30. So just like 6 was talking about the number of rolls, and just like 1 was talking about the number of the preferred event, in this case being a 2, is equivalent to the ratio unknown number of preferred event occurring out of how many rolls?
30.
Out of 30 rolls. Class, write this on your paper right now. Then, of course, as per usual, and you might see another way, it's okay, at least know for sure how to always do cross multiply, divide by lonely number. What do you get, class? 5. Do I have any questions on how we now know our answer of how many times is the cube expected to land on a 2? We would say what number? 5. Exactly 5. Okay, move on to item number 2. Here we have a spinner. It appears to be equally spaced with how many items? 3. 3 colors, 3 numbers, whichever they're talking about. Let's see. A student council is holding a fundraiser. Students can spin the spinner shown how many times? Twice. So we're going to be doing 2 spins. And they do receive a homework pass if red is spun twice. Ooh, those lucky kids. Have I ever given you a homework pass? No, because I want my kids doing their math homework every single day. So sorry, guys. You deserve it, but you don't want it because you want the math practice. I'm confident. All right, here we go. So shown twice, if they do it twice and red is spun twice, then they get a homework pass. Based on the theoretical probability, how many students out of 270 are expected to land on red twice? So again, class, they want us to use theoretical probability of landing on the color red. How many spaces in the spinner are red? 1. Please write a 1 as your numerator. Out of how many spaces in all? 3. This also relates to if we were to spin the spinner 3 times, we would expect it to land on the red 1 time. Now, that's on the first spin. How many spins did they talk about? 2 spins. So do I also need to do this ratio for the second spin? Yes. So underneath my second arrow representing my second spin, I will say what? 1 out of 3. Guys, do you realize how I knew it was the same? Because the probability of red is still what? 1 space out of 3 equally sized spaces. Are you following how we got 1 out of 3 again? All right. And what will I do with these 2 probabilities to get my overall theoretical probability? Multiply. Class, 1 times 1? 3 times 3? You got it. So what is the theoretical probability of landing on red twice? 1 out of 9. How many times are the students going to play this game or spin this spinner twice? 270. So across from my 1 number preferred out of 9 spins total, equaling blank number preferred out of how many spins total? 270. You do the math right now. You have your handheld calculators there. 270 times 1. You don't even have to do times 1. It's still 270. Divide that by 9. Raise your hand when you have an amount. Go.
30.
Who agrees with 30? You should, because it is correct. So when they ask you, how many students out of 270 are expected to land on red twice? Class, your answer in a moment online will be 30. Excellent. Let's move on to number 3. When playing a board game, Leilani rolls a number cube twice. Oh, here we go again. When you roll a number cube twice, if you're only looking for one number, what is your probability on the first roll? 1 out of 6. What is your probability on the second roll? 1 out of 6. Let's see if that's what she's doing. In her past 10 moves, she's rolled 2 5s once. Oh, what is it she's trying to roll? 2 5s. How many times does she expect to again roll 2 5s in her next 30 moves? Compare this prediction to the theoretical probability of rolling 2 5s. So class, let's talk about the theoretical probability first. Please remember, this is the probability that is completely and totally based on numbers. For example, if you're flipping a coin, 1 out of 2 times you expect it would land on heads. 1 out of 2 times you expect it would land on tails. Now, if you flipped a coin 100 times, will it for sure turn out 50 times heads, 50 times tails? No, it won't for sure do that. But theoretical probability is what you're guessing it will be really close to. All right, so we're going to do the theoretical probability first. How many numbers on a number cube say 5? 1. So what is the probability of rolling a 5 on the first roll? 1 out of 6. Multiply that by the probability of running a 5 or rolling a 5 again. 1 out of 6. Excellent job, guys. 1 out of 6. Multiply your numerators, multiply your denominators, giving you a final amount of 1 out of what, please? 36. Okay, we want to be sure we multiply numerator times numerator is 1, denominator times denominator is 36, yes? Okay, great job. Thank you. All right, so save that, and remember that 1 out of 36 is your what? Theoretical probability, your TP, your theoretical probability. Now, shall we find the other probability, the experimental probability? We can get that from the following sentence. I will underline it in my blue. In her past 10 moves, that means rolling the die twice for a single move, right? In her past 10 moves, she's rolled 2 5s. How many times? Once. I would like you...
Teachers, pardon interruption.
Hold on.
Pardon interruption. We need Emery Rawson for checkout.
Okay, that person's not in my room. I'm not worried about it. Okay, in her past 10 moves, she's rolled 2 5s once. So I need you to create a ratio out of that event occurring one time. What goes as the numerator of this ratio? Okay, notice it says she's rolled 2 5s once. Out of her past what? 10 moves. So let's do this. Remember how the number you put at the top of your ratio is always the number of the preferred event you're looking for, right? The number as the denominator is the number of possible outcomes or the number of tries that you do. Her number of moves, yes? Okay, so if she tried to roll 2 5s in a row, if she tried 36 times, we're guessing that probably one of those times she would land 2 5s, right? Okay, so now we're using the experimental probability because they are telling us what happened when she did roll the cube playing the game. First of all, think about the numerator. What is the number of times that her preferred event of rolling 2 5s actually occurred? Notice the numbers I have circled. One says in her past 10 moves, she's rolled 2 5s once. What number is my numerator? Please say it if you know. I'm glad several people knew. It is 1. Because only one time did her preferred event happen. Out of how many total tries? 10. Do you at least now follow how we get 1 out of 10 tries? Okay. Now their next question is this. If, let me erase so I can reread for myself. It says, how many times does she expect to again roll 2 5s? What is rolling 2 5s? Isn't that her preferred event? Yes. How many times does she expect that to happen in her next 30 moves? So now I need to go back and relate that to the theoretical probability as well as the experimental probability, which is what your 1 out of 10 tries was. So across from both of my ratios, guys, I'm going to erase some of my writing because I feel like it starts to get looking a little too busy. All right, and I'm going to give us space across from each of these. Across from theoretical probability, do you agree I have 1 out of 36? And I want to compare that to unknown number of times out of what? They're asking about her next what moves? 30. Do you understand why that is my number of tries? Yes? So 30 goes on the bottom here. What will I now do with my numbers to find how many times it's likely to happen in the theoretical probability? I'm going to cross multiply, divide by lonely number. Please do that now. Cross multiply, I get 30. Divide by 36. What do you get? Obviously, it's going to be less than 1. Go ahead. Okay, is it 0.83 repeating? Okay, I'm going to make this a complex fraction then. 0.83 repeating 30ths, yes? Okay, now I'm going to compare the 1 out of 10 tries equaling blank out of, what's the total number of tries they're asking about? What's the total number of tries we just worked with? 30. So now we're seeing what it's likely to be out of 30 again. Okay? So 1 times 30, divide by 10. What amount do you get?
3.
Okay? Yes, 3. Correct. So 3 times out of 30. Now that we're comparing out of 30, is it easy to tell which number is greater? Which amount is greater? The amount for the theoretical probability here or the experimental probability here? Experimental probability. Great job. The larger probability is the more likely to occur. Do you follow that? So because the experimental probability is 3/30, while the theoretical probability is less than 1/30, can you tell very easily that this is the greater and therefore the more likely? All right, let me erase all of that as we go to item number 4. All right, true confessions. This took this teacher quite a while to figure out, but I did not give up. I kept trying and trying again. And now I know how to work backwards a little bit better than I did before. Everybody follow, please. 10 green marbles are added to a bag containing an unknown number of marbles. Y'all, I'm not even kidding. I drew myself a little picture. It looks like an apple with a core sticking out, doesn't it?
Onion.
Or an onion. Okay, yay. I have successfully drawn an onion when I was trying to draw a bag. I'm so talented. Yes. Okay, don't tell anybody. All right, so I'm going to put 10 green marbles in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Label those green. Plus unknown number of what? Red, because they say containing an unknown number of red marbles. Do you understand my sketching a scene? Sometimes that's just to help my brain calm down and realize it's going to be okay. I'm going to solve it. Suppose 2 marbles are removed at random. We've done experiments like this before. This experiment is repeated 9 times, and then we notice that 4 times 2 red marbles are chosen. Based on this, the experimental probability they just told us about, based on this, predict how many red marbles are in the bag. Now, just admit by show of hands. Wave if you're like, OMG, I have no idea how to begin this, and I don't mind admitting it. Okay, raise your hand if you think you have it entirely figured out and you could immediately tell the class how to solve it right this second. Okay, yes, I haven't found anybody yet all day. I've got a pretend hand over here. If I call on him, he's going to say, no, I was just stretching. Okay, so anyhow, here's how this goes. Suppose 2 marbles are removed at random. Let me tell you the rules they failed to tell you, and maybe that would have helped the children. I'm just going to say, McGraw-Hill math people. So, When they say 2 marbles are drawn at random, here's what they mean. You reached in the bag, you pulled out 1 marble, you recorded the color, you put that marble back in the bag, shook the bag up, then you reached in and pulled out your second marble, wrote down the color, put the marble back in the bag. Don't you agree? It's very important to know that they keep putting the marble back in the bag every single time. Otherwise, you would have a different denominator for the first pull of a marble than you have for the second pull of a marble, wouldn't you? And so I wish they had told you that. So you have to assume that it's done in the way I just described. Now let me ask you this. Every single time that we have learned about doing the very same spin of a spinner or roll of a number cube, what do we always end up multiplying by each other? Ratios that match or ratios that don't match? We always end up doing ratios that match. Refer back to the item with the number cube. We ended up saying on the first roll of the cube, they had this many chances of rolling a certain number, 1 out of 6. And then we multiplied that because on the second roll of the cube, what do they also have as the likelihood of rolling that number? 1 out of 6. So then we get a 1 out of 36 overall probability, right? Okay, that is what we're thinking about right now on these 2 pulls of a marble. Are you seeing how the pull of a marble is like the roll of a cube is like the spin of a spinner? Yes? Okay, so for yourself, I want you to go ahead and draw a box to represent an unknown ratio. We still don't know it because we do not even know how many red marbles are in the bag yet, do we? Okay, but we do know that on the first pull of a marble, there is a certain probability of pulling a red marble. We just don't know yet what it is. Don't worry, I'm guiding you there. And then I also know that on the second pull of a red marble, there was the what? Same probability as on the first pull of a marble or different probability from the first pull of a marble? Same probability. Because remember, we keep putting the marble back in the bag. Are you following? Okay, so here we go. Don't give up yet. Here we go. Suppose this experiment got repeated 9 times and that it happened, 2 red marbles were chosen 4 times. Now, look at these 2 numbers I have just written for you. They repeated the experiment, repeated it 9 times, and then the number that was preferred, or the event that was preferred, happened 4 times. Take my numbers, fix them so they make the correct ratio. Raise your hand if you feel like you know the ratio that we should create, that the overall experiment did. Okay, go ahead and tell me. You are absolutely right. I don't know why other people were scared to say that because great job. Okay, so how many times, class, did the preferred event occur? 4. So that's why 4 is your very first number that you are writing. Okay? Number of preferred event. Yes? Okay, please be sure you've written this. And then out of, what's the total number of times they tried?
9.
Out of 9. Remember, that was the total number of tries. Always the number of preferred event happening here. Always the number of tries, or the total number of tries, happening on the bottom. Now that I know 4/9 of the time, overall, they were able to pull 2 red marbles, then I know 4/9 has to be equivalent to these 2 ratios I set up earlier that I did not know. So now I'm going to move 4/9 up here and equals. So I wonder what I could do with 4 to find what number multiplied times itself would equal 4. Class, what number is it?
1.
It is not 1. 1 times 1 is never going to be 4. 1 times 1 is always going to be 1. I was very much hoping you would think about what number, when multiplied times itself, would equal 4. Class? 2. Now, what do we say 2 is of 4? It is the what? Square root. So you are correct. Fill in a 2 for the numerator of both of those unknown ratios. But now we're about to know them. Now that you recognize we did the square root of 4, to find the unknown numerators, because remember, the only thing we knew is that these two ratios match. Do you get how we knew these two ratios are identical to each other? And that is why you would want to square root what? Both the 4 and the 9. What is the square root of 9, class? 3. So let's check to see if this pans out. Does 2 times 2 equal 4? Yes. Does 3 times 3 equal 9? Yes. So on the first try of pulling a red marble, the chances were 2 out of 3 pulls of a marble, it was going to be what? Red. And on the second try, 2 out of 3 pulls of a marble, it was going to be what? Red. Do you see how we worked backwards with the 4 knights that they gave us? Okay. Now that I know that 2 out of 3 times it would be red, I also know that 2/3 of the marbles are red. So hold on a second. How many, or what fraction of all the marbles would therefore be green? Okay, I need you guys to develop this skill. Whenever you see that 2/3 of a set are one color, and you only have one other color you're dealing with, and you only have one whole bag of marbles, if 2/3 of the bag are red, then what thirds of the bag are green? 1/3. Do you follow how you should understand that? You need these units to add up to one whole bag, right? Okay, so now that I know 1/3 are green, and I know they told me that 1/3 equals what? The green number was? Okay, guys, in the problem, you do have it in front of you, yes? It says 10 green marbles. So if I know 1/3 of the bag are green, then don't I know that 1/3 of the group of marbles is 10? And if 1/3 equals 10, then 2/3 equals 20. So how many red marbles are in that bag? 20. Excellent job. Please write that down. All right, in honor of this being our last day, I'm going to keep helping you guys on several of these and then let you go enter your answers because I want you listening. I have too many people who have struggled with certain other items here, and I need you to at least listen to the thinking. I might leave you with the space to finish solving it on your own. Number 5, a circle then a heart is chosen 4 out of what? 50 times from the cards shown. Find the relative frequency. When they say relative frequency, they mean of the experimental probability. Then compare the relative frequency to the theoretical probability. All right, let's find the relative frequency. How many times do they choose first a circle, then a heart? 4 out of 50. Class, write 4 out of 50. And that is equal to your what probability? EP, experimental probability. Now let's find the theoretical probability. For theoretical probability, what are the chances of first drawing a circle card? 1 out of 4. How did you know? Because only one card has a circle. And how many cards total? 4. So 1 out of 4 for pulling a circle. Now I need to multiply by the probability of pulling a heart. How many cards have a heart? Write a 1 out of how many total? So what is the total probability, theoretically speaking, would be what? 1 out of 16. Equaling the what? Theoretical probability. Now, we're going to talk about comparing it just for a moment here. If I need to compare these two, what would be an easy way to tell which one is bigger than the other? What do you think you could do? Tell me.
To tell, okay, so I think 4 out of 50 is the bigger one, and to tell that, it's,
There are a couple different ways you could do this.
50 is halfway to, 100, so if you multiply that by 2.
Okay.
100, and multiply by 4 by 2, it'll be 8.
Okay. So then you would know it's 800ths. And then what could you do with 1 over 16?
You could find out how much you multiply 16 to 100.
Okay, great.
And multiply 10 by 4.
Yes. You could turn 1 over 16 into how many hundredths, right? Now, guys, what could you do on a calculator to find out the decimal value, which would give you the number of hundredths? What could you do on a calculator with 1 over 16? You could do 1 over 16. So you choose whichever way you wish to do it later. I am going to quickly tell you my quick way to solve it mentally. I say to myself, you know what? I want to get the number 50 as close to 16 as I can so it's easier to compare. I want to get my numerator down as small as I can so it's easier to compare to 1. So I do this. If I simplify 4 over 50, what would it become? 2 over 25. Do you see what I did? I cut both pieces in half. It's still equivalent. It's just a different way to say it. What if I cut both pieces in half again? Which I know isn't easy or convenient, but 2 divided by 2 equals 1, and 25 divided by 2 equals 12.5. So now can I tell which fraction is larger? Is the fraction 1 over 12.5 larger or smaller than the fraction 1 over 16? Oh, we need to talk. If you had a pizza and you're super hungry, do you want it cut into 12 and a half equally sized pieces? That's a little weird, but anyway. Or do you want it cut into 16 equally sized pieces? You want it cut into fewer pieces. The fewer pieces in the denominator, the larger the slices are, right? And since I have it down to 1 slice out of this pie and 1 slice out of this pie has the what slice? Larger. And that was your experimental or your theoretical? Experimental. Great job. All right, go to number 6. This one, tons of children have not understood. So let's look at it for a moment. Maybe one of you can tell me what we should immediately do with it. Number 6, if Riley spins a spinner like the one shown 300 times, how many more times? Ooh, what does it sound like we're going to do at the end of the problem? Yes, excellent. Should she expect it to land on section A than section B? Do you agree? You can tell it's going to land on section A more than section B, right? Right. What should I immediately draw on this spinner? A line that does what? Crosses through A. You guys are brilliant. All right, so that now I have 4 equally sized slices. Do you see what I'm talking about? Okay, so now let's do the theoretical probability of landing on a red. How many of the same size slices are red? 2. Out of how many equally sized sections? 4. Excellent. Now compare the ratio for A happening to the total number of spins they want you to compare it to. What is that total number of spins? 300. Where do I always put the number for the total? Top or bottom? Bottom. So 300. So in a moment, what are you going to do on your calculator? Or right now and write it down, but don't say it. You're going to cross multiply, divide by lonely number. You're going to write that number down. This is the number of times it's likely to land on A. Then you're going to do the same procedure, but wait. Is the B section going to still be 2 out of 4? No. What will the B section use? 1 out of 4. Excellent. And what will you still write across from 1 out of 4? Unknown out of 300. Excellent. You would then cross multiply, divide by lonely number. That will give you this amount. When you get that amount, that's your number of what? B. You should already have written down your number of A. You should write down your number of B and then say again, what is the last step? Subtract to find the difference. Come back to that in a moment. I want everybody's eyes on the next page at the top. Number 7, Mariana rolled 2 fair number cubes for 1 experiment. She rolled a 3, then a 6. How many times? 7 times in 180 experiments. 7 out of 180. How many more times did she roll this sequence than what the theoretical probability would have predicted? All right, so let's go back to theoretical probability. The mathematically based probability, right? What is the mathematical probability that on her first roll of the number cube, she will roll a 3. Say it, class. 1 out of?
6.
Okay. Again, there are 6 numbers on a number cube, and there's a 3 on only how many sides? 1. Do you all understand how the first roll is 1 out of 6? Okay. Now, we don't mind that it's not the same number on the second roll. On the second roll, she's preferring the event of rolling a 6. What is the probability of rolling a 6? Please say it. Okay, I'm really expecting way more kids to know this. So now I see we need to back up a little bit. Since so few of us are saying it, I'm very nervous now. Guys, on a number cube, how many sides have a 6 on them? 1. I'm still not hearing a lot of people. Okay, so everybody in this room, write 1, 2, 3, 4, 5, 6 at the top of your page. Everybody write that. Do we agree that is the sample space on a number cube? Yes. Now, because on the second roll of the die, she's trying to roll a 6. Circle the 6 as many times as you see it. Okay, how many options are there for rolling a 6? 1. Out of how many possible options? 6. Oh, that is much better. And then tell me, what will I do with these 2 ratios? Multiply. 1 times 1? 1. 6 times 6? 36. Now, we're comparing this to how many times that she would be conducting this experiment. How many times? 180. So they want you to compare how many times she would do it out of 180. So where am I going to write the 180? Numerator or denominator? Denominator. In a moment, you will cross multiply, divide by lonely number 36. I don't care if you get a decimal, whatever you get. Write that number here. Do you follow? Okay. Then you will take, this was all the theoretical probability. What is the ratio for my experimental probability? What is the ratio for the experimental probability? They gave it to you. 7 out of 180. So you'll do the same work, but this time for experimental probability, 7 out of 180. And you know what? You don't even have to do the cross multiplying because it's already out of 180, isn't it? They want to know how much more or what is the difference. So you take this number that's your numerator, you take the other numerator that you got, and use those numbers to compare. The last thing I'm going to tell you before I let you start your homework, on number 8, a lot of kids are getting confused, and it's only because they're forgetting that it's okay for them to use 2 different coins. Doesn't a dime still have either heads or tails? And doesn't a penny still have either heads or tails? And in order to find something to do with outcomes of getting at least 1 tail, couldn't you make a sample space by doing the first coin could land on heads or tails, the second coin could land on either heads or tails, and then you can write your abbreviations in here, HH, TH, HT, and double T. I do want you to tell me right now how many of the 4 options have at least 1 tails. I love your answer. This has at least 1, this has at least 1, this has at least 1. So for the theoretical probability aspect of that answer, what will you write? 3 out of 4. And you'll figure the rest out. I hope this helps. Everybody get busy.